This is AP Precalculus review for the final exam known as 3-peat. We are on activity F. All right, in number 1, we're trying to find the end behavior. I see in the multiple choice, I'm asked to go out all the way to the right, all the way to the left for our end behavior. With end behavior, we only really care about the largest degree terms. So these smaller degree terms in our polynomials and our rational functions, we don't care about them. So let's just go ahead and cross you off, cross you off, cross you off, and cross you off. You're allowed to do this when you're dealing with powers like the powers of infinity. Well, not exponents, but just like infinity itself is powerful. So from here, I'm basically going to reduce this fraction. So if I do that, the 4 and the 2 are going to cross cancel down to a 2. And then x to the power of 6 divided by x to the power of 3. This is just properties of exponents. You subtract these because we have division. And this is going to be x to the power of 3. So essentially what I have, this function is basically just 2x to the power of 3 when we're dealing with the left and right behavior. So there's 2 features of this that you need to know. The first, and I think the most important feature, is what's going on with the right-hand side, because it's usually the shortcut that we do later for our sign charts. So right-hand behavior is only dictated by the sign of our coefficient. Is it positive or is it negative? Well, this one is clearly positive. If it's positive, it's going to be going up. If it were negative, it would have been going down. So I know I'm just going to put an arrow on the right-hand side that says I'm going up. The next thing that I have to do to solve this problem is to figure out what's going on with the left-hand side. And the way we do that is we look at the power here. Because we have an odd power, it is going to mismatch. It is going to not match the right-hand side. If the right-hand side is up, the left-hand side will be down. If this were an even number, like 4 or 6, then it would have matched, and the top 2 would have been left and left. So, or sorry, I can't speak right now. It'll be up and up for both the left and the right-hand side. So there's the answer. We just need to write this down. So we say, when we go to the right, we should be going up. So these both say we're going up. And when we go to the left, we should be going down. So the correct answer here is A. What about number 2? In number 2, we have some logarithms. I mean, just generally speaking, in math, if you see 2 logarithms with a plus or a minus sign in between, you want to combine those using your properties of logarithms. So I'm going to rewrite that left-hand side as a single logarithm, log base 2. And the question is, what do I do to these arguments, the things that are on the inside, the x and the 4, if I am subtracting the outside? If you subtract the outside, you're supposed to divide the inside. So it's going to be x divided by 4, and this is still equal to 1. I haven't touched that 1 yet. All right, now I need to get rid of the logarithm. The way that we undo a logarithm is by exponentiating. The way that we exponentiate with logarithms is we look at that base and we say, okay, base of 2, we're going to exponentiate with a base of 2. So it's going to say 2 to the power of log base 2 of all this stuff is going to be equal to 2 to the power of 1. And then I can move down this equal to sign and say that is our new equation. And when we do that, I can now cross off the bases and the logarithms, and I just have x over 4. That's kind of what inverse functions do. And now I have 2 to the power of 1. 2 to the power of 1 is just 2. And then from here, I can multiply by 4, and I get x is equal to 8. Final answer here is going to be D. In number 3, I have phase shift. Okay, so the first thing that I noticed was that there's phase shift. The second thing I noticed is all of these periods are the same periods, which means I can ignore them because there's no differences there. Just multiple choice test taking strategies, right? Phase shift, this minus 2 means I'm going 2 to the right. If I'm going 2 to the right, I'm talking about this point right here because that's 2 to the right. So if I'm talking about this point, could this be a cosine function? Yes, because cosine functions start at a minimum or a maximum. So that is a potential max or a minimum, which is a cosine function, which means we need to have a negative 3 out front, but we have a positive 3. So the correct answer is not A. If this had been a negative 3, that would have been correct. What about B? B is still a cosine function, so starting at a minimum or maximum. We're going to move 3 to the right. So moving 3 to the right is talking about this point right here. Well, unfortunately, that starts at the midline. The midline is characterized by a sine function. This is a cosine function, so it's just immediately not an answer. What about option C? Sine function, so it should be starting at a midline. We're going 1 to the right, so if I'm going 1 to the right, hey, look, I am starting at the midline. And because I have a positive, I should be moving to the top right, and I'm moving to the bottom right. If this had been a negative 3, then it would have been correct, but it's not the case. By process of elimination, the answer is D. Let's see to make sure that we get this right. And I'm moving 3 to the right, so 3 to the right is talking about this point. Yet again, I'll circle it so I remember I'm talking about that point. And sine is starting in the midline. It is starting in the midline, and a positive 3 means I'm moving to the top right, and indeed I am moving to the top right. The correct answer is D. That does conclude our 3-peat F activity. Thanks for watching.